Hi, Math 30-2 students. We're looking at lesson 3.5, conditional probability. This I find is the trickiest lesson to wrap your head around. So if you go to the classwork, and inside the classwork I have actually done out and worked out all the homework questions for you if you are going to attempt the homework. This is the one that is the trickiest to kind of get, so give it time and ask for help if you're not understanding this. So example number 1 for conditional probability, we're going to use this formula, this from your formula sheet. So there's this formula that comes up a lot. So I'm going to actually write it at the top of our screen and use this guy a lot throughout this lesson. So this means that you're finding the and. So the keyword that you should be looking for in questions is the word and. Versus the previous lesson when we were looking at mutually versus non-mutually exclusive events, you should be looking for the keyword or. So when they say and, you might have to have conditional probability. So what it's saying is you're taking the probability of A and multiplying it with the probability of B if A already happened. Okay, so you're saying that this event B is being affected by what happened right here, which is A. Okay, so that is conditional probability. So for example, Jackie played on a volleyball team called the Giants. The Giants are in a round-robin tournament with 5 other teams. The teams that they will play against will be selected at random. Determine the probability that their first game will be against the Clippers and their second game will be against the Maroons to the nearest hundredth. Okay, so we want to figure out the probability that they will play the Clippers and, you see that keyword? And then they'll play the Maroons. So Clippers will be first, and then Maroons will be second. So your probability A is the first event that occurs is the Clippers, them playing against the Clippers, multiplied by them playing against the Maroons if they've already played the Clippers. So in this one, there's just one kind of equation that we have to work with, nothing too crazy. So Clippers, well, we know that there are 5 other teams other than themselves, right? So if they want to play against the Clippers, there's going to be one team that's the Clippers out of 5. Multiplied by, well, now they want to play the Maroons. How many teams are left? Well, there's going to be the Maroons that they're playing, and there's only going to be 4 teams left since they've already played the Clippers. So once you play a team, they're out of it. So we have one less team, and that's why it is conditional probability, because our second fraction is being affected by what happened first. And lastly, all we have to do is put this into our calculator. It says it wants the answer to the nearest hundredth. So you're going to go 1 divided by 5 multiplied by 1 divided by 4. And you're going to get 0.05. So this is your probability of playing the Clippers first and then the Maroons. Example number 2. So a computer manufacturer knows that in a box of 100 chips, 3 will be defective. Jocelyn will draw 2 chips at random from a box of 100 chips. Determine the probability that she will draw 2 defective chips. Whenever they want 2 of something, it's always going to be this kind of conditional probability. So that's like a little hint. If they ever want 2 of something, you're assuming you're taking one out and then you're going back and taking another one right after it out. So they want the probability of A and B. So they want the first one to be defective, meaning not working. And they also want the second one that they pick out of the box to be defective. So that's going to be probability of A multiplied by probability of B occurring if A already happened. Well, let's go into the box and take out your first defective chip. We know that there are 3 defective out of a total of 100. So probability should always be what you want out of 100. So what we want is the defective chip out of the total. Multiplied by, now we want to go into that same box and take another defective chip. Well, we already took out one defective chip. If we go back into the box, now we're going to only have 2 defective because we already took one out. And in our box, we now have 99 chips left once we took one out. So this is going to be our conditional probability, our new value. All you have to do now is put these into your calculator. 3 divided by 100 multiplied by 2 over 99. And I'm going to actually simplify this as a fraction. It gives you 6 over 9900. And what you can do is divide the top number by 6 and the bottom number by 6 to get 1 over 1650. So that is the probability of taking out 2 defective chips. Example number 3. Hillary is a coach for a junior ultimate team. So ultimate is like volleyball. Or I think that's frisbee actually. So ultimate is frisbee, I believe. Based on the team's record, it has a 60% chance of winning on a calm day and a 60% chance of winning on a windy day. Tomorrow, there's a 40% chance of high winds. There are no ties in ultimate. What is the probability that the team will win tomorrow? Well, the issue with this, guys, is that she can win in 2 kinds of cases. She can win if it is windy, and her team can win if it is calm. So for these, where there's more than one situation or more than one case where she can win, I like to do a tree diagram for these. So I find a tree diagram helps a lot with these situations where there is more than one case. Okay, so the first case is we're going to have to look at all the potential situations that can happen. Well, the first situation that can occur is weather. That's always the starting event. So what is the starting event that winning depends on? Well, it's weather. Well, the weather can have 2 situations. It can be windy or it can be calm. So you need to find out those probabilities first. Well, there's a 40% chance of high winds, so we can put 40% here, and that means that 60% will be here. The reason being is all branches should add up to 100 if you're doing it properly. Now, we're going to find out the next part. This is like her winning versus losing. So she could win if it's windy, and she could actually lose if it's windy. So that's the next part, the next branch. Same thing. Here, if it's calm, she can win or she can lose. Her team can lose. So from this information here, we know that she has a 60% chance of winning on a calm day. So we're going to put 60 here, which means that this has to be 40 because they have to add up to 100 for this to make sense. And we know that there's a 70% chance of winning on a windy day. So that means there's 30% chance of losing on a windy day. Now, in order to get winning, we're going to have to look at 2 parts of the branches. We're going to have to look at windy and winning. So this and is in between here. And we have to look at calm and winning. Whenever we see the word and means multiply. So we're going to have to multiply between those 2 values. Now, in order to put these into your calculator, you're always going to put them in decimal form. So 40% is 0.40 and means multiply. So we're going to multiply it by 0.70. So these 2 numbers here, multiply them, but in decimal form. Same thing here, 0.60 multiplied with 0.60. So we need to find out the answer. We get 0.28 here and 0.36 here. When it comes to cases, when there's more than one case, we always have to add between the cases. So you're going to add the 0.28 and the 0.36 to get 0.64. So that is actually our probability to the nearest 100 that their team is going to win tomorrow. Now, how we know that we're doing this properly, how we can check quickly for errors, is that you should always be checking these numbers here. These should add up to 100, these should add up to 100, these should add up to 100. That's a quick little check. Also, we're going to do C first, and then I'll show you another way to check with the answer from C. So we want to now know losing. So I'm going to go back to my chart here and I'm going to highlight losing. So losing would be on a windy day, I can lose, and on a calm day, I can lose. Okay, so I'm going to do the same thing I did above, but for losing, windy and losing would be taking 0.40 and multiplying it with losing, which is 0.30. And it can be calm and losing. And that would be 0.60 multiplied by 0.40. One answer would be 0.12 and one answer would be 0.24. If you add them together, you get 0.36. Now, the way of checking is if you take winning plus losing, that's going to give you every situation that can happen. For example, winning was 0.64 and losing was 0.36. If you add them together, it should equal 1. All decimals, when it comes to probability, if they add up to 1, that's your total. That's every option included. So that's a way of checking to see if you got the right answer. Add your answer here and add your answer here, and they give you 1. So that is our check. Example number 4, Nathan asked Riel to choose a number between 1 and 40, and then says one fact about the number. When it comes to numbers, I always like to use the Venn diagrams. So going back to the set Venn diagrams really helps to organize my information here. So Riel says that the number he chose is a multiple of 4. So that's kind of like the first event, the first set. And we know that there's going to be an intersection because we want to know the and part. Like we want to know we're going to be given the intersection and we're going to use that. So Riel says that the number he chose is a multiple of 4, so that's the first event. Determine the probability that the number is also a multiple of 6. So we know 1 to 40. Multiples of 4 would be like this. 4, 8, 12, 16, 20, 24, 28, 32, 36, and then 40. So we need to write out all the multiples. And then for 6, we need to write out the multiples of 6. 6, 12, 18, 24, 30, 36. And so those are them. Now, which ones are both? That would be the intersection. So we're going to write these as probability. So all these answers should be out of 40 if you're doing this properly. So we know that these are the intersection numbers, the numbers that are both in common. They both have in common. Okay, so there are 3 out of 40 numbers that occur for both situations. So when we're looking at our equation, probability of A and B is equal to probability of A multiplied by probability of B if A already happened. Well, we know the intersection. This is our intersection between the two sets. So we can already fill this out with 3 out of 40. The probability of A would be this entire circle, this whole thing here. Okay, so all this part right here would be the intersection. So let's find out this entire circle, what it should add up to. If you count out all these numbers here, that's the answer out of 40. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 numbers out of 40 that are multiples of 4. So that should be your first probability occurring, 10 out of 40. And then the last part is just to solve this. It's just about doing math. To isolate for this, you need to bring this to the other side. So it's going to be 3 over 40 divide, because they're currently multiplying, so you want to do the opposite. Divide both sides by 10 over 40. And that's the probability of B occurring, meaning being a multiple of 6 if you already know it's a multiple of 4. So in your calculator, you're going to put brackets around 3 divided by 40, and you're going to divide that answer by brackets 10 divided by 40. And you should get 0.3 as your answer. So the answer for being a multiple of 6, if it's already a multiple of 4, is 0.3. The next answer, or the next example number 4, is pretty close. The only thing is they're asking for a little bit of a different number. So you do have to kind of fill this out again. So we know that the intersection between a multiple of 6, so I'm going to start with that being first, and a multiple of 4 being the second event. We know that the intersection is still 3 out of 40. But what they're saying is that this event occurred first. This is our new starting amount. So we need to actually find out that whole thing. Well, if I go back, I'll use actually a different color so that way it's not confusing. So let's choose yellow. So this is yellow, right? So we know that the whole circle of yellow should add up to, if you count them, there are 6 out of 40 numbers that are multiples of 6. So when we're doing our formula, it's still going to be set up the same, except our first event occurring is that this is a multiple of 6. We already know it's a multiple of 6. They're saying what's the probability that it's also going to be a multiple of 4. So we also already know this is going to be the same. The intersection is still 3 out of 40. But now our first event is going to be 6 out of 40, the multiple of 6. So we want to find out the probability of the number being a multiple of 4 if we already know it's a multiple of 6. So we're trying to solve for this. It's the same work as before. You're going to take 3 out of 40 and divide it by 6 over 40. If you put that in your calculators, don't forget to put brackets around these guys. And once you do that, you should get 0.5. So that's your final answer. Now, example number 6, I find is the trickiest one to wrap your head around. So just bear with me as long as you kind of like understand these ones. These are like the previous ones are the most common scenarios. This one's like the confusing, weird one. That's just try to follow along as much as you can. So it says, according to a survey, 91% of Canadians own a cell phone. Of these people, 42 have a smartphone. So it's not about solving for it. It's just knowing where these numbers go in the actual equation. So that's the tough part. So our equation for conditional probability is this. So our first event is someone owning a cell phone. So knowing that they own a cell phone, what's the probability that it's a smartphone? So it's like knowing that they have a smartphone. So what's the probability that it's a smartphone if we know they have a cell phone? That's what that kind of area describes as. And this one's being the probability that a person has a cell phone and smartphone. So the math isn't hard because they're telling us that 91% of Canadians own a cell phone. So that's our probability of A. So we're going to write it as 0.91. So always take these percentages and divide it by 100. And now being a smartphone, it's this word right here that tells us where this should go. Of these people, so meaning of these cell phone owners, 42% have a smartphone. So that's actually your smartphone if we know that they already have a cell phone. So that's the 0.42 going there. And now what we're solving for is A and B. So you'd put that into your calculator and you get 0.3822. They want the answer as a percent, so you're going to multiply by 100 and get 38% as a whole percent. Now we still need the previous information, but they want the nearest percent, the probability that any Canadian you met in the month would have a cell phone, but not a smartphone. So probability of A intersecting with B is equal to probability of A multiplied by probability of B occurring if A already happened. So they want cell phone and not smartphone. Okay, so the first probability is still cell phone. So that doesn't change. Our previous number is going to be the same. It's still 0.91. But we want to figure out how many of these people do not have a smartphone. So what we're going to do is we're going to go back here. Remember, we had 42% of them had smartphones from the cell phone users. So we're going to have to go 100 minus 42, and that's going to give us 58%. So we know that there's 0.58 as probability of people that do not have a smartphone, so not a smartphone. So these are the people that own that don't own a smartphone, but it is a cell phone still. Okay, so that's the only slight differences. We had to go back and use that 48 and subtract from 100 to get that 58%. And if we multiply, we get 0.5278, which if you multiply by 100 gives us 53% as our answer. So that is your lesson for conditional probability, lesson 3.5. So I hope you guys understood this. Now, if you're attempting the homework, remember all my work is already on classwork. So check on classwork under the probability unit, and you'll see all my work if you are attempting the homework questions. This is a really tricky lesson, especially in the homework, so in the textbook. So if you are struggling, make sure you ask for help.